Good afternoon. My name is Nalewabau. I'm a program manager in Visual C++ group working on C#, and I'm here today to talk to you about advanced C#. I'm really excited and really proud actually to be here today, not only to sort of like talk to you and introduce you to some advanced topics, but also to represent the work of the team that's been building C# over the last year and a half or so. I actually have two objectives today. The first is to obviously introduce you to programming topics that we think are advanced and that we think that advanced programmers, frameworks developers, architects and those sort of things will be interested in knowing that C# can do. What I'm going to do is we've chosen 5 areas. I'm going to drive into those areas, show you the motivation behind those areas about why you'd want to use them, and then step you through some code and demo some stuff. And my second objective today is actually to defy the demo gods. If you've ever done a presentation, you know demo gods watch you at every stage. And I've been working pretty hard to put together a set of demos that work all the time and that, you know, like a visually appealing, those sort of things. And I've actually been spending the entire week up in the speaker room showing all the speakers my demos and actually being very confident about them. In fact, so confident that I actually irritated quite a few of them. They actually set a challenge to me, and I'll tell you what that challenge is just so you'll know the sort of extra pressure that I'm under today. The challenge is if all of my demos go correctly and they don't fail, some of my co-speakers are actually going to chip in and buy me, or actually upgrade me to a first-class seat for my trip home to Seattle. So I thought that was a good deal too. Unfortunately, there's always the other side. The other side is if any of my demos fail, for each demo that fails, I have to do 10 push-ups. And I'm doing 10 push-ups in the speaker room just where they can see me. I'm doing 10 push-ups right up here during the Q&A session so you can all see me do them. So just so you know, that's the sort of pressure under here, right? To take the demo gods on today. I know it's the second last day and the second last session of the day, so you may be a bit tired. I'm just going to try and go through at a very quick pace just to go into quite a few demos that I want to show you. And I just want to keep it really upbeat for you. I know it gets a bit tiring towards the end of the day. So with that, let's have a look at what we're going to talk about. We've actually got 5 topics that I want to talk to you today about. The first one is extending the type system. You've already heard Anders, if not in the previous session, but on the first day when he was talking about Introduction to C#, talking about ways in which you can extend type system in C#. What I'm going to drive in today is actually how you go and create primitive types or the value types in C#, how you give it functionality via user conversions and operator overloading. So I'm going to walk through actually creating a primitive type with you in the language in the IDE. The second thing I'm going to talk about is creating and using attributes. I just heard Anders talk about how important and how integral attributes are in the framework. I'm going to show you how to create them. I'm going to show you how to attach them to types and members, and then I'm going to show you how to reflect on them at runtime and add some functionality to it. The next 2 points that I want to drive into really fall under the umbrella of API integration. How do I talk to my existing code? The first one of those, how do I talk to my existing DLL functions? I've got code in DLLs, how do I get access to them from C#? The second point of that is COM support. How do I talk to my existing COM objects? We'll talk about some really quite advanced features that C# has for doing that. We'll talk about when you need to do that and when you may not need to do that. And the last point I want to talk about is C# and pointers. We'll talk about the unsafe block of code or the unsafe modifier that you can use in code to actually allow you to use this. We'll talk about some of the scenarios in which you need to do that, and then we'll actually step into some code and show you that. So that's the agenda. So let's get straight to it. And I'll probably won't talk as long as I'd normally do to this slide because of Anders just having done the presentation. Essentially, most users think of 2 types of objects. We think of real objects, things like a customer object or an order object. And then we think of primitive types, things like ints, floats, and bools. And we all have these internal expectations of what these types are and how they perform. And we actually have different expectations for each, and I just want to drive into 3 of them. The first is that we all expect that real objects are more expensive to create. If I create a customer object, that's got to be more expensive than just creating an int. And we have that expectation, you know, that's how the system performs. The second expectation I have is that primitives always have a value. If I have an integer, I always expect it to have a value. If I may not have assigned it a value, but it may have got a default value like 0, but I always expect it to have a value. I never expect to walk up to a primitive type and say, are you null? The second, or the third point is that we expect to have primitives and we expect them to have operator support. I expect to be able to walk up and add two integers together using the plus operator. I expect to be able to take two floats and use the minus operator to subtract things from them. So there's sort of like some expectations that we've had. I know Anders talked about the traditional solutions, and I'll just go over them very quickly. I mean, a traditional solution is just simply make everything an object. I mean, conceptually, that's very simple. If everything's an object, then I'm just, I don't have to worry about this. Well, the problem is that has a lot of performance implications. If I'm writing a mathematical library that's using ints all over the place or complex numbers or things like that, I don't want to be creating an object and doing a heap allocation every time I allocate an object. The second thing is I have this behavior and expectation mismatch. I'm creating an int, and that's just as expensive as creating a customer object. Not exactly, but it's still in the same range of performance issues. The second solution is actually a little bit more interesting. It means we're going to support both. So I'm going to support real objects and these primitive types, but I'm going to restrict the user to only being able to define real objects. And that's quite an interesting design decision, because that means the language designers or the compiler designers actually sat down and said, right, I'm going to define this set of predefined primitive types that you can use. So I could imagine that they'd be sitting around and, of course, we need int, bool, float and things like that. But then where do they draw the line? How do they know what constitutes a primitive type? If you're someone building a graphical library, you probably think that classes or types like a point and a rectangle are primitive, because they are to you. You're creating millions of these things. If you're creating a mathematical library, you're probably thinking that a complex number is going to be a primitive type for you. But unless the language designers themselves have sort of like said and given it and blessed it as being a predefined type, you don't get to do that. You only get to work in the real objects, and so you incur all of the performance problems that we were talking about before. That's an interesting design decision to make. And we'll talk about how C# addresses this issue, but I just want to drive in effect, just keep driving on in terms of classes and look at what would happen if you tried to create a class that represented a primitive type. So the example that I'm going to use throughout this entire part of the presentation is a rational number, basically something that has a nominator and a denominator, like a half or 3/4. And you can see that if I did a class-based solution, it'd be very simple for me. What I could do was I could actually instantiate two objects. I could probably write methods on there, say add a rational. So I could add R1, R2 by using the add rational method. And then I could probably write some sort of conversion operator, sort of method that would take a rational and convert to, say, in this case, a double. Okay? And if usable, I could see how I could do that today. Now, it's not probably as nice and as simplistic or tactically as nice as we'd like it. So you could imagine that I could add, if our language supplied, some form of operator overloading and conversions. So I could write some code that looks like this. I could still instantiate my rationals. And then I could take advantage of some sort of like conversion. In this particular code, I'm doing a conversion from an int to a rational. I'd then obviously want to be able to use more natural operators, like the plus operator here, to be able to add these two rationals together. And again, in the bottom one here, where I actually want to convert that rational to double, I probably expect to use some sort of casting operation to do that. So you can imagine I have a class-based solution here. I have, operator overloading that looks like it's doing what I want it to do tactically, but there's actually a problem with this. And it all comes down to the fact that the rational number is a class. So what are some of the aspects of being a class? What's the generic behavior of a class? Well, effectively, it's heap allocated. Every time I go to create one of these things, I'm going to have to do a heap allocation. Obviously, because things are on heap, they could actually be null. So I'm going to have to now test for all my rational numbers to see whether they're null before I can actually do some activity on them. Probably the more insidious problem is that actually equal assigns the reference and not the value. So if I have two rational variables, I create one pointed at an object, and then I assign the value R1 to R2. These two rationals are sharing the same reference to the one object. If I manipulate the chain between one of them, it's going to be reflected in the other one. And that's definitely not the sort of behavior you want from a primitive type. You can imagine all sorts of havoc if I was doing that with ints and things like that. Again, one of the problems with actually having a class is that when I actually allocate things like an array, I'm actually allocating references, not values. So in this particular example where I create 100 rationals, I'm actually creating 100 references that are all null when in fact what I really wanted was 100 rationals that have their default values. So there's a lot of problems with actually just keeping it as a class. And that's what happens if you're in a language or in an environment where you can't actually define primitive types. So what's our answer in C#? Anders basically talked about it, structs. Structs provide the answer because basically they have some fundamental behaviour differences between that and a class. And let's look at those differences. The first is that they're stored in line and they're not here allocated. That's a fundamental difference. That provides basically a lot of the functionality that we want from a primitive type. Because they're not stored in line, because they're not allocated, they can never be null. So they'll always have default values. An assignment on a struct actually copies the data and not the reference. So basically address the three fundamental issues that we were talking about classes. Structs have fundamentally different behaviour to classes, and they provide excellent groundwork for building your own primitive type. There are obviously implementation differences between classes and structs. The first is that struct always inherits from object. It's just one of the fundamental differences between them. And that structs always have a default constructor. You need to always be able to create a struct and get its default values. Like if I'm doing an array initialization, I need to be able to give it its default values. So structs will always have a default constructor. So let's look at building this rational number. What I want to do is actually walk you through building a rational number as a struct and look at how you do things like conversions and operator overloading in C#. So the first thing you'll notice is that the way I modify or actually declare a struct is just by using the struct keyword instead of the class. But from then on, it actually looks like a class declaration. I have constructors. Here I have some properties. These are read-only properties here that are returning the numerator and denominator. Sorry. And I can actually override methods. The fact that rational ultimately derives from object means I can override methods like the toString method. When you look at that of what it looks like in code, you can see I can do things like instantiate a rational number, and I can just call methods on it called toString. So there's really not a lot of functionality there, but we've got the basis of something. We have something that's not going to be allocated on the heap, that it's actually going to be put on the stack. It has default values, and that I'm able to actually add properties and add methods to it. But it's not useful yet, really, a primitive type. The first thing you're probably going to have to do when you're building a primitive type is write conversion operators. And these are conversion operators between one type to another. C# actually supports two types of conversions. The first one's called implicit. An implicit conversion means there's no loss of data. So an example here is if I take a rational number and I actually convert from an integer to a rational. I can always take integer 2 and create a rational number 2 because that's just 2 over 1. There's no loss of data in that conversion. The way you define your operator or your implicit conversion operator is just a public static method. It has an implicit keyword here and an operator, and then it defines the types that are involved. So in this case, I'm taking an integer and I'm returning a rational. That's how you do an implicit conversion in C#. Once you do things like this, that means you can write code that just assigns an integer directly into a rational. That will cause the implicit operator to be called, and you'll get a rational number back. The second type of conversion that's possible in C# is an explicit one. And this basically indicates that there could be a possible loss of precision. So when I do the conversion from the type back to the other type, there could be some loss of data involved. And potentially it could actually throw exceptions. So an example of this is just from the real world. If you took an int and you tried to convert it into a byte, obviously there could be some loss of precision there because the value of the int may be outside the value of the byte. So that's an explicit conversion. The way you write those in C# is very simple. Again, it's just a public static method on the class, the struct. It uses the explicit keyword rather than implicit. And again, this is just convert here between a rational and a double. So what we're saying here is that there's an implicit conversion from rational to double. And when the user actually goes to call this code, this is what it looks like. I can create a rational here, and I can take this rational, and I can convert it to a double. And the way I indicate the user, or the way the user has to indicate that they want to use that operator, is via casting. So it's the normal syntax for indicating this is going to happen, and potentially I could lose some data. So that's pretty cool. I've got my struct now, I've done some methods on it, and I've done some conversions. So I can assign into and out to of types. The next thing I'd probably want to do is do some operator overloading. And we'll look just now at how you can add the plus operator to the rational type. Again, it's just very simple. I have a public static method, it returns a rational, it takes two rationals here. So effectively, this allows me to write code that looks like this. I can just say rational R3 is equal to R1 plus R2. I'm getting very natural syntax for doing the addition. I can also take advantage of the fact, remember, that we did an implicit conversion, and I can start to write code that looks like this. You can see down the bottom here I have R3 plus equals 2. Well, that's actually causing the implicit conversion from integer to rational and then causing the plus operator to be called. So very quickly you can just define a really interesting or a really nice set of default conversions, start to do some operator overloading and get quite a functional struct from it. The next thing you probably want to do with a struct, and trust me, I'm going to have a demo at the end of this, don't worry. The next thing you can do with a struct is you want to define your equality operator. And the way that's done in the .NET framework is you actually override the equals method that's defined on object. And you may be wondering, why doesn't the .NET framework just use the equals operator? And the answer to that question is because it's a common language runtime. We're supporting multiple languages, and some of those languages don't support operator overloading. So we have a method-based equality. So essentially what you do is you override that equals operator and you provide the right semantics for equals. Now in C#, of course, we support operator overloading. So typically what happens is you override the equals operator and then you define equals and not equals operators to give you the sort of like shorthand operator overloading syntax to call them. And once you've done things like that, you get to write code like this. You can see I can actually say R1.equals R2, or then I can take advantage of the fact that I've overloaded the operator. I can just say R1 equals R2. The second case here, it's just the not equals as well. So it's really quite simple for me to create this type. I'll just go back to that slide because I want to get out the point that I know that a lot of you are probably looking at this and thinking, well, how many times do I define a rational type? And the reason that this is actually here in the C# presentation is we wanted to enable people that are building frameworks to define their own primitive types. I'm just trying to get through the fundamentals of showing you how to do that. So the next thing I wanted to talk about is, besides how easy that was structs and interfaces. And you heard Anne mention that in the previous presentation. Structs can implement interfaces to provide additional functionality. And I remember the first time I saw this and somebody said, structs can implement interfaces. And I walked around campus for a while, for about half an hour, scratching my head trying to figure out why I'd want to do that. And then it's actually a startling realization. The reason you can do that is the same reason classes can. It allows you to plug into different parts of the framework in a really seamless way. And examples of like interfaces that you'd like to be able to implement are things like system.iComparable. Implementing that interface basically allows you to have search and sort support in the collection classes. The one I'm actually going to look at and show you some code today is the system.iFormatable. Basically, that allows you to provide placeholder format for your type. So this is the actual interface. Basically, what happens is system.iFormatable allows you to support new formatting options. So you can see in this particular code down here, I know you haven't had a lot of time to play with the frameworks, but in this particular thing I'm doing a console.writeLine and I'm actually putting in a placeholder operator here and passing in R1. What that will do by default is actually call toString on the R1 and just print out the result. But I can actually provide formatting strings to that call. You can see that I've done that in the second example. I have something called register here. It's actually the parameter number, colon, and then a format string. And by my class actually implementing the iFormatable, I now support having different formats. And if you've ever done C++ and you've done the printf statements and that sort of stuff, it really allows you a very quick and easy way to add your own formatting types to your own, or your own formatting options to your own types. So let's have a look at how I implemented that. The first thing I have to do is obviously implement the interface. And you can see that I can do that here. I've got public struct rational, and I name the interface that I'm going to implement. Then I need to actually provide the implementation of that method. iFormatable only defines one method, one called string format, and it passes in a format string and an iService object provider. iService object provider just provides context information like locale. So in this particular example, what I'm going to do here is I'm going to assign S to be the default value of toString, and then I'm going to test to see if I've got a format string that's come in and it's called reduced, and then I'm going to do some other processing on it, and then I'm going to return S. Most of you are probably looking at this format string is reduced and I'm going, what's going on there? C#, we've overloaded the equals equals operator to actually perform value semantics on a string comparison to make it easier for you rather than reference. So how I use that in code? Well, it's just the code that I showed you before. I can actually go console.writeLine and write it out here, and I can use the format specifier here. And that's the way it looks when it comes out. So I really just wanted to, I suppose, show you the fact that, structs are really valuable things. You get different semantics, you get operator overloading and conversions, make it feel quite natural. And then you can start to do things like implement interfaces on them to provide additional functionality. I should have put this slide up first. Basically, I'm trying to say here that there's the best of both worlds in C#. We allow to define classes and structs. It's you that get to decide what the primitive types are in your system, because you're the ones that best know your applications and your frameworks. There's no user lockout here. We have very natural semantics, and you can provide very natural semantics for your structs by using operator overloading and conversions, and we have interface support that allows you to plug into the frameworks at different areas. Let's go to demo number 1. This is worth 10 push-ups. Right here.
Of course, if you stop now, you're flying first class.
That's true. That's true. I will point out that all these demos ran today, so I think I'm up a level already. So, it just depends what happens here. Oh, I have to do this now. Okay. What I've got here is I've got my whole set of solutions that I'm going to run through today. I'm actually going to spend a fair bit of time jumping in and out of this code. And I just want to tell you that all of the code, hopefully most of the code that I'm going to show you here today will be on the post-PDC CD-ROM. So don't think that you're not going to get this code. It's actually going to be on CD-ROM. So I'm going to spend a bit of time jumping around, but you'll be able to look at this code later on and critique it, send me bug reports, all those sort of things. You can comment on my style of curlies. I know lots of people like to do that. As, of course, you need to do. I'm just going to walk you through the declaration just to show it does exist and it's not just a PowerPoint presentation. Again, here you can see that I have a struct called rational, implementing that interface. I have a constructor. I have 2 properties on it, read-only properties. I'm overriding the toString method. I'm down a bit. I've got my implicit and explicit operators, sort of stuff. I've got my plus operator here. There's my equal, not equals, all that sort of stuff. I really just want to come down here to the bottom of the main and just step you through some code. You can see here I'm creating 2 rational numbers. I can use the plus operator on it to add them. Again, I use the implicit conversion here plus the add. I can do things like call dot equals or override it with call it with the equals equals. And again, right on the bottom here, I'm actually doing some printing out here and using the formatting interface. So let me run that. It's all just going to a console.writeLine. So I don't know if you can see that or not. It actually all did work. So it did work, but that wasn't impressive enough for me for demo. I'm actually going to step you into an area that I think is really valuable, and I just want to, I suppose, go on to an IDE area to show you some of the really cool things that we're doing in C#. So that works. Fantastic type. You can use it. Please feel free to use it. You'll get it in your source code. What I really wanted to show you, though, was you've seen, actually, I'll go back to this old code here. You've seen all these things here. You can see these commenting on the top of a C# method. Effectively, this is what we call our XML documentation method. And you saw Anders talk about how you could do this and get the compiler generated. What I wanted to talk about was how it was integrated in the IDE. So here's a method here that I actually haven't got any documentation on. And what I do in the IDE is press // and I'm going to hit the 3rd slash. What the IDE has done is detected that I'm entering this method and has put in the XML comments for me. We realise it's going to be difficult for people to maintain this all the time. I can then type, and actually I won't because I've learnt not to type too much in demos. I'm booking that first class seat, don't worry. So you can see I'm really typed in and I've got the comments in here. What that means is I can go back over to, let's say, a place that I can call this. And you can see I can do things like Matthew tool. I'll get the IntelliSense. And you can see I can get the GCD. Unfortunately, I can't raise the font on that, but you can see it's got the signature of the method and it's got the description that I entered in my XML comments. So while you're entering code, that's a really great way for you to be able to not only detect the method that you want to be used. And that's fantastic. That's pretty cool. I like that. But that helps me while I'm entering my code. Imagine that I've gone off now and 6 months later I've come back to my code here. I'm looking at this GCD method. I'm like going, what the hell is that? We have a new feature called Quick Info. You can see I can move my mouse over there. It's actually going to tell me the class that comes from, and it's going to give me the XML comment again. So that's a really good way for you to maintain and navigate in your code. It does get better than that. This is my pet feature, so I'm going to... Essentially what we're going to do, it's not in the PDC bits you've got, but you can imagine that you're about to actually start using the system frameworks where you've got a whole lot of space and you've got a whole lot of classes and methods on them and knows what's happening. By Beta 1, we will have the ability inside C# for you to be able to go on things like console.writeline and get the documentation for the framework classes, because that's really what you want. Then, on top of that, we're going to enable people that are building components like yourselves. I don't know how many do it, but I'm sure most of you will build components at some stage and deliver them up to other groups, whether that's in your company or whether you're selling those components. We're going to enable you to actually distribute your XML documentation with it, so people who are consuming your components will be able to get your comments as well. And on top of that, we're actually going to enable you to be able to localize that information as well. So if you're delivering components overseas, you can actually have localized documentation with it. Yeah. Demo number 1 out of the way. Sorry, what was that? That's actually something that we're not planning on. You can come and talk to me because it is my pet feature and I could put that in. Probably not at this stage. I hope my manager's here. He probably doesn't want to hear me say that. Oh. Oh, sorry, was there a question? I'll take questions at the end, so I'll try and get through the slides, but certainly I'll take questions at the end and I'll be available at Ask the Experts. So the second thing I want to drive into today was actually creating and using attributes. And you've probably heard a lot about adding attributes. You've probably seen people adding things like web methods and things like that. You're probably wondering what they are. So let's talk into and have a look at what attributes are. Again, Anders went over this in the last presentation. I'll just give you a recap. The problem that we're trying to solve with attributes is how do you associate information with types and members? Things like documentation for your class, transaction context for a method. How do I know that a method requires a transaction or doesn't support a transaction? Those sort of things. How do I associate design time information with a class? So if I'm building, say, a component and putting it in the toolbox, how do I know what sort of help should come up? What category should appear under the toolbox? So traditionally, those solutions have been disconnected. I've had to write a class and then I've had to find some extra information. Now, that could have been in an external file, like an idle file or a def file, but then I need some way to bind those together, whether I use a tool for that, whether I use it's disconnected from the actual definition of what a component is. I could use some sort of naming convention. I could create the rational type, and then I could write the rational info type and have some sort of naming standard or naming convention that try and tie those together. But it's still disconnected. What we want to do in C# was have an integrated solution, and that's what attributes are all about. And before we dive into attributes, I just wanted to show you what they look like in code. I know you've probably seen this, so I won't spend much time. But effectively, an attribute just basically looks like a class instantiation here using square brackets. So this is basically saying here, I'm attaching the help URL attribute to the class here. In the same way, I can actually attach attributes to methods. So I'm attaching the obsolete attribute, which is one that's a framework, to some method, saying, well, you should be using another method instead. And in the same way here, this is not an attribute, it's just one I made up, but basically it's just showing you the ability to attach attributes to parameters. So it's really quite a simple syntax. You just use the square brackets, it just looks like a class instantiation. I'll just walk through a couple of the fundamentals before we dive into the code. The thing that we really want to get across to you today is that attributes are classes. It's a generic mechanism for users to add your own. Okay? Again, we didn't want to define a whole set of attributes like web method and all the things that we would think of and then help you guys out. The idea is that you can create your attributes and then you can add those and give those to your users to put on their classes and to perform some functionality. Again, attributes can be very easily attached to types and members. It's a very simple syntax, that square bracket. And the real key is that once the attributes have been attached, you can query them at runtime using reflection. And I'll walk through some code that shows you how to do that. Here's how you create an attribute. As again, it's just a class. It's derived from sys.attribute. The way to really think about it is that the class functionality is actually the attribute functionality. I'll talk about that in a sec. But here we go. We've just got a class here called help URL attribute. I have it derived from sim.attribute. I have a constructor that takes a string. I have a property here that's returning the URL for the help URL attribute. And I have something here called a read attribute called tag. We'll get onto that in a second. But essentially, it's just a class. It just looks like a class. All the only thing is that it's derived from system.attribute. So how can I use attribute now that I've defined it? Well, I can start to attach it to things. In the first example here, I'm attaching it to the class. And I'm just attaching some sort of URL to the particular class here. So I'm instantiating help URL, attaching it to the class. Some of you may be thinking, what the hell's going on here? In the last slide, I had help URL attribute. In the next slide, I'm using help URL. We realise that that's a fairly common naming pattern. In fact, you'll find it throughout our frameworks. When you see something like web method attribute, it actually corresponds to a class called web method attribute. Essentially, there's a naming pattern that's going on here that's saying, well, if it ends in attribute, it could potentially be an attribute class. What the compilers do is actually allow you to shorthand that. I just wanted to point that out because if you go looking for web method, you're going to find web method attribute in the help syntax. I want to explain why that was there. So that's fairly interesting. I can just create a class. It just looks like I'm instantiating a class. In the second example here, it looks like the same syntax up here, but then I've added a comma and I've got something called tag equals ctool. And what that's actually referring to is attributes have the concept of required parameters and named parameters. Required parameters really just corresponds to the constructor argument. They're things you need to provide in order to create that attribute. What a named parameter is, and I'll just jump back now to the definition of the attribute, is any public property that's read-write. So that's a named tag is actually characterized as a named parameter here. And the reason that that's important is we recognize that people are going to build attributes and they may have a lot of optional parameters. We didn't want somebody to have to write a huge constructor that had lots of different options just for the different things that people could write. So we said we have required parameters that represent the constructor arguments, and then we have named parameters, which are the public properties that just allow you to basically add, optional information. The third example down here is just showing you how you attach multiple attributes to the one type. You see, I can just use the comma there to actually show you. So it's really simple. Now, I've created the attribute class. I've attached them to the type. How do I query this information? How do I walk up to a class or a type and find out what sort of attributes it supports? Basically, the answer is reflection. You can see in this code snippet here, it's quite straightforward. I can use the type of operator in C#. I pass in a class, and it returns me the type object. So this is the type object that represents my class. I can then call a method on type called getCustomAttributes. That returns me an array of objects which represent the attributes on that class. This is the only time in which the attributes get created. I know some people sort of get a bit confused. They're saying, well, I've attached them, so when I create the type, and the system creates the type, doesn't that mean all the attributes get created? No. They only get created when you actually want them to be created. And this is by actually when you call getCustomAttributes. That's the only time those attributes get created. So essentially, I get an array back. I can use the for each operator, for each expression to iterate over that collection. And you can see here that once I can just test to see if there's a help URL attribute, I can cast it, and then I can use it as a strongly object. So it's a really simple process. Just walk up to the type, up to a method, ask it for its custom attributes, and it will return them to you. Sorry? Is? No, I'll explain what that is later. The is not the same as type of. So here we go to the second demo. The thing that I wanted to show you here, that you'd see what I was doing. They're all going fine. Everything's fine. No, everything is fine. Sorry, there was no reason to. What I'm actually going to do is I'm going to run this application, just show you what it's about, and then we'll step through the code. What I've basically written here is a small WinForm application that allows me to type in here the name of a class. I can then, name of a type really. I can then hit the Get Information button and it will walk up to that type and ask it for its custom attributes. I'm actually detecting whether they have two types of attributes. One is called a help URL. So I'm going to look for a help URL attribute, and if it's there, I'm going to put it into a linked label that will exist here. I'm then going to look for something called program notes, which is an attribute I dreamed up, and then I'm going to put any programming notes into this list box. When I click on the link that's going to be here, I'm actually going to display the HTML going out to that file and getting the HTML, and then to display it in here. This is actually IE embedded inside a WinForm here. So I'm actually showing, ActiveX hosting in a WinForm as well. So let's just have a look at the code associated with that. First, let's just look at how I've defined the help URL attribute. You can see that it's just a help, it's just a class here, it's derived from system.attribute. I have a string here. I'm passing in the URL, I'm just storing it as a string, and I'm just got a property that will give me the URL back. The second thing I'm going to show you is the programming node attribute. And let's just ignore that line first and come down and have a look at it. Again, it's just a class that's derived from system.attribute, and I'm storing just a string, just a note to do with it. The line above here, and this confuses many people, but after a while it sinks in, is an attribute that can apply to this class. And the attribute, it says where this attribute can be used. In the previous one, I didn't specify anything, which means it can be attached to anything. What I'm saying here is that my attribute targets are all, so again, I can attach this attribute to all, but in this case, I'm using a named parameter of it called allow multiple, which allows me to add multiple of these attributes to one particular definition and multiple of these to a class. You can actually, there's another name property called inherited, which allows you to inherit properties from types, and that's an interesting concept as well. So now that I've defined those, how do I attach them? Well, again, this is pretty simple. I have a thing here called my class, and I've got three attributes attached to it. I've got a help URL, where I'm passing in the string for a URL, and I have two programming nodes. You're looking at this and thinking, what is that? That's something in C# called a verbatim string. What it actually means is I can put an @ sign, and then I can put a double quote, and then anything inside that string, there's no escape sequence, there's no escape processing going on. It allows you to get around the problem of having to do the double slashes all the time, trying to figure them out, all those sort of things. It's also a really useful feature if you're doing XML or you're doing regular expressions and all those sort of things. It's a really nice and quick and easy way to do strings. The second example here, I just have my class, and I've only attached two things. I've attached a help URL and a programming note. This is really just to keep me honest while I'm running this demo. So let's go ahead and hit the button here. Again, what I'm going to do is it's actually going to go off to the type and ask it. It's going to, actually, I didn't show you that code. There we go. Here is the code that's actually associated with actually pressing that button. Let's come down here. The first thing to do is go off and get the type. I actually got a string name here, and I'm actually getting a type object back. If it's null, I'm just going to pop up a message box. If it has got values, though, I'm just going to go up and ask that type. I'll just scroll across a little bit here. I'm going to go up and ask that type for the custom attributes and iterate over them. First thing I'm going to do is, if the attribute is a help URL, I'm going to set the link label to the text. Set the link area here is doing the underlining. And then I'm actually just going to say, if it's a programming note, I'm going to get the programming note, and I'm going to add it to the list box. So let's go back. Let's hit the button. So again, this is doing the reflection, walking around those types. So you can see here that I have a URL. I'm going to click on that. Again, this is using IE hosted inside a WinForm here, and I've actually just got some sample HTML that came from the SDK. I can take advantage of the WinForm support for resizing controls, so I can just nicely grab that out and create it. And now just to make me honest, I'll go off and get the other class. Again, this is just some sample HTML that comes with the SDK. Not an Easter egg, I'm told. So, this is just showing you the ability to walk up and start to query this stuff information. You can imagine now, you could invent your own set of attributes on your organisation, have a whole set of attributes. Some people are talking about adding attributes for code reviews, being able to walk to a type and actually ask for a code review that would tell you what was last reviewed or something like that. People are going to start dreaming up all sorts of things. This is a really quick and easy way for you to add this stuff and then easily being able to walk up and query this information. So that's the attribute demo. 2 out of 5. We're going all right. Okay. And I promise I won't muck around with the IDE until you get back so you can see what I'm doing. The next area I want to talk about is DLL imports. So how do you talk to your existing DLLs? So the .NET framework, surprisingly, contains attributes that enable you to call into existing DLLs. That's the reason I need to talk about attributes first, so we can explore into, I can actually show you how we use attributes within the framework. Within the system.runtime.interop services, there's a whole series of attributes that allow you to control DLL names, entry points, parameter, and return value marshalling. So you can attach these sort of attributes to a method and then get it to call out to external methods. This is basically the idea. You can use these attributes to call in your existing DLLs. Obviously, we don't know what's in your code, so we can't provide you with a wrapper for it. What I will point out is that all the system functionality that you expect, the WinForm2, the GDI, the kernel, all those sort of things, all of that functionality is already in the frameworks. You don't need to call those out. Okay? So the framework's providing a lot of functionality. In fact, a lot of the demos that I'm going to show you, I could do more easily in the framework, but I really wanted to point out some of the advanced features and who would talk to stuff. So effectively what we're saying is you can use these attributes to attach them to DLLs or attach them to methods to call existing code. This is what it looks like in code. Quite straightforward. Again, you can see that I use a DLL import attribute. Basically, you can mark a method as being static extern, which means it's not defined in here, it's defined somewhere else. The DLL import attributes and the other associated attributes that you can use in that namespace provide the way or the marshalling information, so at runtime we know where to go and get this call. I'm using calls here that are obviously from GDI32, and again, I just told you that the frameworks provide all this functionality, and yes, they do. I'm doing this because I don't have any DLLs of my own. I treat GDI like it's my DLL, so you won't need to actually do this if you want to create a pen and do these sort of things, but I'm just showing you the technique of being able to call out to a DLL function. The second example here is very straightforward again. I'm calling another function, the GDI32, and I'm setting the char set named parameter here. Effectively, this is controlling how the marshal is going to marshal strings across. There's actually a string, a log font object here. So that's saying you do automatic char set, whether it's empty or whether it's, it's just controlling the marshalling for the string when that call is made. Again, it's just a static extern method. So it's quite straightforward. Just attach these DLLs, these attributes to those methods, you can call in. We're getting right into the demos now. There we were, back at the IDE. All I was doing before was closing all the documents. See how confident I am. Setting the startup project here and just setting the configuration so I only have to build this one project. What I'll do is I'll run this code first and then step through the code again. The idea here is that this is basically a screensaver written in C#. What we're going to do is take an image of the actual desktop as it is, and then we're going to draw, you probably all seen just like a classic bees running around on the screen, leaving trails and blanking out the screen. So again, I'll just run this. There we are. So this is just using GDI calls, getting the desktop, painting some things, doing some logic for the bees. I still can't figure out the logic for the bees. But they're all running around and doing stuff and basically painting your screen black. Let's have a look at some of that code. The first one is just a whole set of DLL imports. Again, I'm just using that DLL import attribute from the system.runtime interop services namespace, and I've just got a whole bunch of GDI tools here, or user32 and GDI as well, mixed in. Getting desktop window, all those sort of things. And probably one of the key things to note about this file, I won't go into detail with everyone, is that there's not a lot of attributes that are attached to, say, parameters and things like that. That's because the default marshalling in the system actually does a pretty good job of actually marshalling all those parameters across and doing all that stuff for you. So it's actually quite a straightforward and simple way for most APIs to be able to do this. So you shouldn't have a lot of trouble doing that. Of course, once you've actually got it in and you've got a method here, you can just call it. So again, here's just some calling code. This is in the paint window. I'm just creating pens, doing all the logic there about moving them around and painting trails, and then just objects. They just become like normal methods to me from then. I don't need to know. So it's a very straightforward way for you to get access to your existing DLLs. Just use those bits. Again, you'll be getting all of that code. You can see that I'm obviously a software guy. There we go. So that was actually just using DLLs. Now I want to talk about COM support. Most of you have a lot of existing COM classes, and we wanted to make it very easy for you to call those. The .NET framework actually provides great COM plus support. You basically shouldn't have to do anything to talk to your existing COM object. There's two tools in the SDK that you'll see that provide this like functionality. First is called TLB imp. That's a tool that imports your existing COM classes. So you can use that tool, point it at a COM class, it will create a wrapper for you, and you should just be able to call that class, or call that class through the wrapper. The second is called TLBX. What that essentially allows you to do is take your .NET classes, say your C# classes, and then expose them so your existing COM objects can call them. And to a large extent, most users will actually have seamless experience in using these tools. In fact, inside Visual Studio, you won't see them at all. You'll just drag, you'll say, I want to reference this, this COM object. It will go away and call these tools invisibly and behind the background for you and create these things. So to a large extent, you actually won't need to do the sort of things I'm just about to show you. Now, we recognise that sometimes you need total control, you need more control. Sometimes you can have methods that have very complicated structures. And as talked about this, you can have a structure that has pointers to other structures and all those sort of things. And in some cases, the default marshalling just can't handle that. So you need to be able to specify that with more fine-grained control. The second scenario in which you sort of need more control is if you have a large TLB. The two tools that I mentioned, or actually the TLB imp tool that I mentioned, takes a TLB and converts all of the classes into a wrapper. And sometimes you only need a few of those classes. You don't want all TLB. So you may want to have a more fine-grained control in the way that tool runs. Again, there's a whole series of attributes inside the system.runtime.interop services namespace that you can actually use to actually provide an interface or actually be able to describe existing COM classes. And the sort of things that you can provide, or the sort of attributes there are, things to do COM object identification, there's things to do parameter and return value marshalling, some H results behavior. And I just want to talk about the H result behavior for a second. In C# and indeed in the whole .NET framework and in the common language runtime, the standard way of handling errors is exception handling. This presents a problem because the standard way of doing things in COM is with H results. The default marshalling for the runtime and the framework will actually convert invalid H results to exceptions because we want everybody in the framework to be dealing with exceptions. So if it gets an invalid H result, it will actually generate and throw an exception you can catch in your code. So by default, that's what's going to happen. You can use these attributes to change that behavior if that's what you want. Most people will leave it with that behavior, but you have the ability to control that. So let's have a look at what one of these looks like. Here's the active movie control, the interface to the media control object. And you can see this is how I define the interface. I have an interface here, and I have a GUID that marks that interface. Very straightforward. So I have an interface here. I have all the methods that the interface provides. Again, you can see that the marshal is being done automatically here. I'm not doing anything to control that marshalling. And I have an interface there. Really straightforward. Just use the attribute. So let's go to the video player demo. What I'm going to do here is I'm going to show you a piece of code. And I Nothing up my sleeve. Here we go. I'm going to show you some code. As you can tell, it's getting late for me. Of actually creating and using that active movie control in a C# application. So you can say here, I do want to point out, by the way, the active movie control, I ran it through TLB, it's fine. I could just use it as it was. I didn't need to do this at all. I just wanted to be able to point out the fact this is how you would do it if you wanted to control it. You can see here that I can define a class, the manager here. I can give it a GUID. I use the com import attribute on that. You can see here that this is the real meat of the thing. I have an interface here with a GUID. And again, I'm just defining the methods here. Notice that I'm not doing anything else on the marshalling of the parameters. How does that get used? Well, once I've defined those interfaces, it's really quite straightforward. My IDE is slowing down me. That's not a good sign, but I shall prevail. I'm actually going to show you the application in a second, but I've actually got an open dial. I've actually got a file open arrangement here, and I'm popping up a file open dialog. See that I'm just going to show the dialog, and if I get a result, I'm actually going to create the manager, and then I'm going to cast this interface. What it's actually doing is I'm actually co-creating that object based on the GUID that you saw in the thing, and then actually doing a query interface on that object just by doing that cast. So again, this is fairly straightforward. I've just got, those attributes are defined in those com objects, and I'm using this, and you can see here that I'm actually getting the quick there with the XML documentation, which is my feature. And you can see that I'm actually just being able to cast to that interface, and then I'm being able to use that interface to call methods and run on. So let's have a look at this running. Can I mark it as the startup? Yeah. Okay. David, can I get the video? Again, this is the open dialog that's in the system. I'm just going to open up the blind.avi file and let the movie player run it.
I can't believe it. It's my first blind date.
Oh, I do it all the time.
Really? You guys meet? Greg, Janice?
We sure did.
We've got chemistry here. You feel it?
I felt it.
All right, Janice.
Sometimes when my wife's talking to me, I say, all right, Janice. She doesn't know what I'm talking about. It's like, all right, Janice. So that's just a very quick example of how you use those sort of objects if you needed to. Again, you should have a seamless experience, but this gives you the ability, those attributes give you the ability to control those things. I told you I was going to wake you up. So. Okay. The last thing that I'm going to talk about today is sharpened pointers. I'm going to talk about why this is a necessary feature, talk about some of the scenarios in which you want to use it, and then end off with a great demo. A great demo. There I go. I've given it the kiss of death already. Why do we need this? Well, we recognise C# that sometimes developers need total control. And we recognised there was a couple of major scenarios about why this was required. The first was there's a whole set of performance extremes. Sometimes you're not getting the performance that you need and you want to drop down. You need to be able to use pointers, you need to be able to do pointer arithmetic, you need to be able to do unsafe casts, you need to be able to do something to get the performance. I'll just jump to the third point, the advanced COM support and DLL import. This is a primary way in which you can actually create structures, complicated structures in your, say if you had a COM interface that had those screwy structures with pointers to structures, all those sort of things. This is the primary mechanism that you can do to create those complex structures. Again, if the default marshal fails, this is where you can turn to. An interesting example of why you'd need unsafe, or perhaps you don't really need it for it, but it certainly makes code a lot easier, is dealing with existing binary structures. You can imagine that somebody's written a code, or you have files in your system that have a C structure, that have just basically been written out, and you need to read those in files. Now, a way to do that, I've got a code snippet in a second, I'll make it talk to the point. But the basic problem is trying to deal with an existing binary standard. I have some binary format on disk, I need to read that in, and I need to map it to some sort of structure. C# provides an unsafe modifier that allows you to marker class or a block of code, and essentially that allows you to use this limited inline C. Now Anders has just gone over it, so I'll just quickly run through the things. It allows you to do things like declare pointer types. It allows you to declare, use pointer arithmetic. You can do unsafe casts. And you can also do declarative pinning, the fixed statement. The sample that I'll show you will talk about that. And the real essence and the real key that is in the language is that we really want C# developers to have headroom. We didn't want you to hit the wall. We didn't want you to sit there and say, look, all I needed to do was like allocate a few things, fix this structure up in pointers. Now I have to go to native code, I have to use com interop, or I have to use platform invoke, the DLL imports, to try and do that. We didn't want you to hit the wall. We recognised there was times in which you needed to do this. We didn't want you to go outside of the box. So that's why we have the unsafe. So here's an example that I just talked about. Most of you, well, some of you may have seen this. In the Windows 32, there's a cof header, which is basically the header that sits in front of an executable. It describes things like the machine type, the number of sections, the characteristics. So all of that is actually in front of an actual executable. There's a feature here that sits there that defines that information. I'll get that back in a second. How would I read that in? I mean, essentially, if I was just looking in a normal, if I didn't have unsafe, well, I could do things like, I could just open up a binary file, grab a byte out at a time, know that the first thing was a usual, try and combine the bytes together, convert them, all those sort of things, stick them into the struct. I could do that. It's probably quite error-prone. It's probably quite slow. It's quite difficult for me to do that marshalling, understand those mappings. This is an example of when you may want to use the unsafe feature. And let's have a look at some code that's actually loading this in from a binary file. So here we have a struct again. We're going to declare something called the cof header. And we're going to call a method called readHeader. You can notice that I have to use the unsafe modifier on the method. Essentially, once I've marked this method as being unsafe, I can start to use some of these inline C mechanisms. One of them is actually the size of operator here. I can actually go and read in bytes to the size of that cof header. So again, this buffer will actually just read in a whole bunch of bytes into the buffer. What I can then do is fix buffer and declare a pointer to it. Effectively, what fix does is fix this area of memory and give me back a pointer. And in this case, we're getting a byte pointer back. I'll go on to the next statement. I'll come back to the fixed. Essentially, once I have a pointer, I can then use normal dereferencing on pointers to be able to basically move or essentially copy that data into that structure, essentially doing the entire overlaying of the structure on that binary buffer in memory. And that's something that most C++ programmers would be used to, and it's certainly a useful technique if you want to do this sort of things. So again, this is just an example of what you want to do here, what potentially you could do. I just want to step back to say about that fixed statement, and when I said to you that it actually pins, we call it declarative pinning, it's actually pinning that memory. And I don't want to imply to you that there's actually a cost involved with that. Essentially what happens is that it marks that area of memory, and the garbage collector will, no garbage collection occurs that affects that memory. You don't pay any cost. If the garbage collector comes around and wants to move that memory, it's going to see that it's been tagged as being pinned, and it won't be able to move that data until the block of the unsafe block is finished. So it's not like as soon as you say fixed, it's going to move this memory around and move it onto a safe area. It only has a performance impact if that actual memory is actually going to be garbage collected. So that's a lot of power, and it comes at a price. Essentially, as soon as you start to introduce unsafe code into your code, into your assembly, you effectively have unverifiable code. Because you could be doing unsafe casts, you could be doing all sorts of stuff in there. What that means is that you have stricter security requirements on when it runs. You basically have to be fully trusted for that code to run because you could be doing anything inside that unsafe block. So that's the pros and cons that you have to weigh up. You're going to have to weigh up the power of using that in that facility against the stricter security requirements that the execution environment is going to actually impose on it. So let's bring it all together. The last demo that I'm going to give you is called the intern project, largely because I made my intern write it. I kid you not, this guy has slaved away on poor Anson is his name, and he slaved away on it, and I basically gave him these requirements. I said, you've got to use operator overload, you've got to use attributes, you've got to use com support, support, and you've got to use unsafe. The two other requirements, which are probably more important, is it needs to be visually appealing and it needs to make me look good. And I don't know whether you know that Microsoft interns get reviewed in the same way that we get reviewed, and they get review scores. And I've actually said to him, he's not here by the way, I've actually said to him that his review score will be totally based on your reaction to this demo. So just keep that in mind. So I left my poor intern alone for a while. He's actually a quite bright guy, so he didn't actually spend that long on it, which was quite frightening. And this is what he came up with. He built a DirectX demo. He basically built a WinForm application that displays Quake 2 models. I don't know if many of you have played Quake 2. I've certainly played too much of it. And Quake 2 has a set of models. They're basically a set of, basically a list of triangles that basically define shapes, like the player shape, the monster shapes, all those sort of things. And then it uses an engine to render that, so you get the monster running at you and those sort of things. So what he basically wrote was a WinForm application that had two direct draw surfaces. You can see the first one here is actually double buffered. So essentially we have a direct draw surface here. We have one off, if you use the graphics, it's like we have a buffer off in the background, and we do all the drawings to it, and then we flick it to the front vertically to avoid flicker while we're actually drawing into it. The interesting thing about that is he actually went off and created a COM interface, or used COM attributes to actually describe the direct draw interface in COM. We then went off and basically performed WinForm events. So you'll see me, I'll be moving this thing around with my mouse. I'll be moving, rotating it, sort of things, and reacting to WinForm events. And then what we do, and this is a really crucial part, so I'm going to probably belabor it a bit. All the calculations for the triangles here, so you see there's a bunch of triangles here. All the calculations for where those triangles are, how they're positioned, all those things is done in C#. He's got a whole bunch of structures, he's got these data structures in, doing them all in C#, and only when we get to the end, we need to draw those lines, that's when we go out to DirectX and drawing. So effectively we're doing a lot of the rendering here, we're just using DirectX as a drawing surface. So, let's see if my first class ticket is intact. There's people out there sweating at Coast speakers. Start warming up at the seat. You can see why they probably thought I was irritating. My wife says that too, I don't know why. I'll actually run the demonstration, show you a few things, and then time permitting, I actually don't have that much time, but I'll try and step through some of it to show you. I'm actually negotiating with Anson about giving this, I'm actually trying to get him to, we'll clean up this code and actually give it to you as part of the CD. Obviously all the code I've currently shown you will be there. This one's probably a bit more complex, but I'm hopeful of trying to get it to you. I think I just have to mention review scores to him and there should be no problems. You want to work for me? No. So I'll just run it first. Oh, there we go. So again, I'm just going to point out this is a WinForm application. There's two direct draw surfaces here. There's the primary one that you're seeing and there's a background one. This is a Dragon Knight model. This is actually not from Quake 2. It's from a guy called Michael Mellor. I know way too much about Quake models. This is actually just a custom model that this guy's built. So again, we have a whole bunch of triangles here. I'm just going to move this triangle around. We have clipping area problems there with the lance, but you can see I can rotate the model. Remember that all of the calculations are happening in C#. I'm doing all of the calculations and then redrawing direct draw surface. And I don't want to pretend to you that I'm just moving this around slowly, right? So there we go, we're off crazy. So those of you who play Quake will know that there's a whole set of standard animations that come with the model because you want to be able to make the thing look lifelike. You want to be able to make the thing when it's standing there to do something that actually appeals. So we've actually, so notice how I use we. Anson has actually got a whole bunch of the stand animation here. And I'm going to press the play button now. What's actually going to happen is we're going to set a timer off. Every 100 milliseconds, we're going to adjust the timer just to make it feel as if it's moving. So every 100 milliseconds, we're going around in C#, we're creating all the triangles, we're doing all the stuff, and we're drawing it. So I looked at that and I said to Anson, that's pretty good. Meanwhile, I was looking over my shoulder like, wow, look at that. And said to him, I know this is probably not going to show up very well. I said, wireframe doesn't really cut it, mate. It needs to be texture mapped. So there it is. I know that probably doesn't turn out very well on your screen, so I'm going to be at the Ask the Experts and I'll have my laptop here running so you can come up and have a look because it's actually quite impressive to see. In fact, I'll put it to a vote. I have 10 minutes left. Do you want me to walk through the code, show you this here, or do you want to just start taking questions? Because you can come and ask me the question at the Ask the Expert. Anders will be there. Most of the members of the team will be there. Who wants to see the code? All right. I'll have to give him I'm just going to run this again because I just want to show you that hopefully there might be another model that will show up better. Just to show you too that we haven't sort of like... This is a knight with a flaming sword. I'll map him. So this is just another model. In our hunt for models around net before the PDC, you should have seen it. We're like looking at it like, no, good enough, all that sort of stuff. So, all right, so let's have a look at the code. Sorry? I just won my ticket too, by the way, so... Might just start yelling at them from first class, like, hey, did you notice that all my demos worked? Here we go. All right, so I'm just going to go very quickly through this code to show you, because there's a lot of features being used here. Here's a struct that represents a matrix struct, the type that he's got. You can see here that he's done some operator overloading, so he's done the times. Doing that enables to do things like just walk up to two matrices and multiply them together using that operator. Again, just a simple syntax there, but it makes his code much more readable. Obviously, that MDL file is actually in a file. It's stored as a file and it's got a C structure at the header, so we need to read it. Here's an example here of where we actually walk in. We have an unsafe block here. We have an unsafe method here. I'm just reading in the bytes again to the size of that header, and then I'm calling a method called parse header. Inside the parse header, what I'm effectively doing is again, you saw in this code snippet before, but I'm fixing the memory, I'm getting a byte buffer back to it, and I'm just popping that value over. I'm directly overlaying that structure on top of it. So very quickly, so I didn't have to hand parse that. Again, there's that I. Here's the interface that he defined for the direct draw surface. You notice that he only actually used, I think, 6 interfaces out of this thing. So he didn't bother to find the interfaces. He just needed to take up the slots. So you can see here, we have a blit operation. So here's a bit that takes a rectangle, takes a direct draw surface, draws to that surface on the source rectangle. Sorry, I'm getting late, but you can see that I've actually done the XML documentation here. I've just sprinkled it everywhere. So that's quite simply define that surface. How did he create the direct draw surfaces? Again, just created the objects, then started calling methods on it, like direct draw create here. By the way, this is a Pentium 2 laptop too. It's quite slow, so when you saw that rendering, it's not like I'm using a really whiz-bang box up here. See, I'm creating the direct draw objects here. Sorry, I should say answer. And then I'm actually creating, just creating surfaces, just calling these methods now as if they're just normal. Again, I've mapped them in. Here's the code that talks about the timer event. I just wanted to prove here that we're just walking through the model. So you can see here, here's the timer that's going off every 100 milliseconds once I hit the play button. I'm just testing, I'm going to use I, and I'm only saying Anson. Okay. So, I test here to see whether the MDL has been loaded, and empty the world. This world list typically contains the whole bunch of triangles that we saw that made up the actual model. You can see here that all I do basically is I walk around. This actually functionality is not actually in there. You can actually put multiple models on there. So, but we only have one model loaded. And we're basically just updating the sequence count to get the new triangle positions. And then we're adding it to the world list again. And the thing that we do down the bottom is that we invalidate the panel that we were looking at, so the screen, the screen that we could actually see. What that basically meant was the panel was being invalidated. We can override the on-paint event here, so we can draw to the direct draw surface. Again, there's that primary and there's that secondary buffer. And if we look at the code here, what he's doing is blitting the colour of the buffer surface to be black. He's then going off and locking the surface of the buffered surface so he can start to draw to it. If he's in texture mode or wire mode, what he's basically doing is going and calling this method here, calling display all. What this is going to do is then take the triangles and draw them to that surface. Once that has been drawn, he actually goes and blits from the buffered surface here to the primary surface. So I've drawn it all on the background stuff here. Now I'm just going to copy it across in one operation, blit it across to the primary screen. Do I get any points for actually knowing what the code does? So this is the real meat of the thing. This is actually now I've gone off, we've calculated where all the triangles can be, we positioned them all. Now all we need to do is actually draw them. You have to be important. When Anson tells me, when Anson was telling me what he was doing, I was like going, oh yeah, that's so obvious. I didn't know why he was doing that. Why he was sorting that list there. He's actually sorting the list because you don't want to draw background ones before the front ones, okay? So you need to sort them in order. So you draw the first, the front ones on. And basically we just look at, for every single triangle, we're coming down here and we're saying, right, are we texture mapping it? If we are, you need to go to the direct draw surface, the pointer to that, and draw a textured triangle. We're putting the textures and all that sort of stuff. If we're just in wireframe mode, so we're just drawing the lines, all we have to do is just draw 3 lines. So we're doing all of the calculations in C#, and we're just going out to the direct draw surface and just, if we're texture mapping, we're going to call it texture map. If we're just using wireframe, we're just going to do the wireframe. So that's a very quick trip through the code. I mean, it should all come up, and I'll be at my laptop and probably have lost my voice, but I can show you through the code and we can run through the demos at greater pleasure. I'll try and get, I will get a version of this code out to you. So just to wrap up, what we covered today was really some advanced issues, extending the type system. How do you build a primitive type in C#? Give it operations like custom conversions, user conversion, and operator overloading. Creating and using attributes, that's a really powerful technique for you to be able to add declarative information to your types. Talk about how you can talk to your existing DLLs, how you can talk to your existing COM objects, and using C# and pointers. Here's some sessions you may want to consider going to. I know there's probably many of these left, but I don't know when they are. Certainly the debugging one is tomorrow. I think the Hello World one is tomorrow. The key thing is the C# language reference is on your CDs. It's installed as part of Visual Studio. I encourage you to have a look at it and give us your comments. We really want to look at like what you think of the language and get a feel for that. The hands-on lab has a whole bunch of C# exercises that you can go and just start to play with the language and have an idea of what it does. And with that, thank you.
Question about external.
Sorry, the external?
I have a question about